want to talk to you this morning about DOD's role and our partnership with DOE. My major message this morning is that DOD is doing a lot in the energy space, but we're not doing it to be tree huggers, to go back to what Secretary Chu said. Don't yet go back, thank you. We're doing it for mission reasons, which is why we're taking it so seriously: cost and energy security. Renewable energy is very, very important in that, combined with advanced microgrid and storage technologies as a way to improve the energy security of our military bases. And as a technology leader, DoD can play an important role in the clean energy revolution in partnership with DOE. Next slide. And this is, Arun told you most of this. We have 300,000, great, thank you. 300,000 buildings, and our building, we have some things that nobody else has: blimp hangars, dry docks, but by and large, our building infrastructure looks very much like the U.S. commercial inventory of buildings more broadly, and that's relevant to what I'm going to talk about later, to us being a test bed for technology. We also have a large natural environment. We are shepherds. We shepherd 29 million acres of land. Half of that is land withdrawn from the Bureau of Land Management. We call it withdrawn land, used for military purposes. We test and train on this land. We are incredibly good land managers. We are probably the best land managers in the federal government because we use the land that we manage. We have a large number of threatened and endangered species, 75 of them found only on DoD installations. The desert tortoise there is a particular challenge to renewable energy development in the Southwest. We're the largest single energy user in the country. We account for 1% of total U.S. energy consumption. 3/4 of our energy consumption by BTUs and 80% by cost is operational energy used for mobility, fuel for ships, tanks, planes, and to power generators in theater. 1/4 of it, or 20% by cost, is facility energy. That's the part that I oversee, and that's the energy used to power our permanent installations, most of which are here in the United States, but not a number of them are overseas as well. We care about facility energy at DoD for two big reasons: cost, even by DoD standards, $4 billion a year. That is our facility energy bill, is real money. And facility energy accounts for a disproportionate share of greenhouse gases because a lot of it is coal-fired electricity. Second big reason: mission assurance. We provide direct support to the warfighter from our permanent installations. This is a switch, or this is a gradual change, a lot of it post 9/11. We used to largely train and deploy on our installations. Now we fly UAV, unmanned aerial vehicles, from our installations. We fly long-range bombers. We analyze battlefield data in real time. We're a staging platform for humanitarian and homeland defense missions. We are 99% reliant on the commercial power grid, and there is growing concern that reliance on the grid puts certain critical missions at risk. Our strategy for lowering cost, our facility energy cost, and improving the energy security of our facilities is to reduce demand for traditional energy, expand supply of renewable and other on-site generation, enhance the security of bases directly, and I'm going to talk mostly about microgrids this morning, and then leverage advanced technology. There is a lot of overlap between these four strategic elements, and the first one is, there we go. It's the most important, but I'm going to say the least about it to save more time for the others. But reducing demand, and here I usually quote Secretary Chu as talking about the energy efficiency being the fruit laying on the ground. All of our new construction must meet quite quite high standards, but we can't build our way out of the problem with 300,000 buildings. So for us, it really is all about retrofits. We have over $1 billion in the FY13 budget for energy efficiency retrofits of existing buildings. That's our own money. In addition, we've made a commitment to do $1.2 billion worth of performance-based contracts. These are energy savings, ESPCs, and UESCs over the next 2 years. And the Army, in particular, has started to incorporate small solar projects and other renewable projects, a couple of megawatts power that will be used exclusively on the base as part of an ESPC. It was not clear that OMB would approve that without a scoring issue. They have, so that's terrific. A lot of culture change in DOD. That's very important. It is a top-down organization, and one can, it's the approach to culture change is different than other places. The Navy in particular, they have incorporated energy performance into performance appraisals for officers. They have started up several energy programs at the Naval Postgraduate School at Monterey, California. So we're institutionalizing the concerns about energy. Expanding on-site generation. This is key. On-site generation combined with storage and microgrids will help make our installations much more energy secure. We have made a commitment to do 3 gigawatts of renewable energy by 2025. Now, the amount is a function of congressional direction, some statutory mandates, but the fact that we would be doing this anyway. We're not doing it because Congress is telling us to. We're doing it because this is a way to make our bases more energy secure, and that's important to the level of commitment and resources that we're putting into this. One reason we feel comfortable making this kind of a commitment is that we have bases that are very, very well suited for solar and geothermal, particularly in the Southwest. My office commissioned a study of the solar potential on 9 installations in the Mojave and Colorado deserts in California and Nevada. It was done by ICF, year-long study, very thorough. They looked at 20 to 40 levels of GIS data for every installation. They concluded that even though 96% of the land, and we're talking 6 million acres, is not suitable for solar, largely because we're testing or training on it, also the desert tortoise, other things, that 4% of 6 million acres is still a very large number. So they concluded that after you taking into account economic feasibility, that there is the potential there for 7,000 megawatts of mission-compatible, economically feasible solar. And they confirmed the strategy that we were already pursuing, which is one of that third-party financing makes sense because developers can take advantage of tax benefits that we can't access. So all 3 services are moving out quite aggressively. The Army has created an Energy Initiatives Task Force, EITF. They put out a draft RFP in February, the final one, which I think will be quite different for those of you who submitted comments. We got a lot of comments. The final one will be out shortly. They have several dozen people now devoted to this. We're working very closely with DOE to see if we can't use our 3 gigawatts of demand as a way to help reinvent the way that renewable energy is financed. Navy has the largest renewable energy facility in DOD, a geothermal facility at China Lake. It's been up and running since 1987. About a third of the revenue goes to the Department of Interior because it's on BLM land. 270 megawatts, although it's degrading over time. On the right is groundbreaking at China Lake for a 14 megawatt PV facility. SunPower is the developer. Navy has been using our 2922A authority. This is authority that allows DOD, unlike I think any other federal agency, to go out 20 or 30 years with a power purchase agreement. They've done that another number of projects in California. They have plans for 28 megawatts in Hawaii. That's for historic Ford Island at Pearl Harbor, site of the attack. That is the plan for a solar PV array that will look like a runway. It will have the runway markings, look like a runway from the air. I met with some folks from Hawaii last week, and I think there are still some historic preservation issues, even though it went through all the process. I think there's still some sensitivity around this, but it's an interesting project. And the Air Force is, they of course have a 14 megawatt PV array at Nellis, which the president toured 3 years ago. They had plans to develop, to double that. I think they're on hold right now. They have just finished a 6 megawatt project with the same developer they used at Nellis at the Air Force Academy. And they're looking at doing a huge project at Edwards Air Force Base in California. They are talking about a 450 megawatt project. This is on fee land as opposed to BLM withdrawn land, so it doesn't have some of the issues that we've still got to resolve with using withdrawn land. But they're also looking at teaming up with Army, being part of Army's EITF effort, which from my standpoint in the Office of the Secretary of Defense would be very helpful so that we don't have three separate service efforts. And then we've got 200,000 units of residential housing. We have privatized all of our family housing, so there's about 8 or 10 developers that own all of it, and Solar City in particular has decided to make this a market. This is Davis-Monthan, one of the first places where PV was put on, where Solar City put PV on the roof of the housing. In addition to reducing demand, expanding supply, which gets at the base energy security on the base indirectly, we're tackling it directly. And I'm going to talk this morning about what we're doing on microgrids, because that's critical. Microgrids are a triple play for DoD. They allow us to operate more efficiently on a day-to-day basis through load balancing, demand response, to lower our costs, improve our efficiency. They facilitate the incorporation of renewable energy, and then most important, they allow us to maintain mission-critical loads if the grid goes down for a sustained period of time. So we are doing a lot in the microgrid space. We have microgrids now, but they're fairly rudimentary. They're typically not tightly tied in with the grid, and they don't have the capability of incorporating renewable energy. So we want to go from the lower left to the upper right, and the two key dimensions on the vertical axis, the degree of grid integration, that determines the degree to which we can take advantage of some of the more lucrative ancillary services, frequency regulation, things like that will, I think in some cases, allow us to pay for the infrastructure. The degree of technical complexity largely speaks to the penetration of renewable energy. The more penetration, obviously, the longer we can island cost effectively, but that creates technical challenges because of the intermittency. So we're doing a lot of demos on that, and I'll say more about that in a minute. We also have 3 analytics studies underway. MIT's Lincoln Lab doing a survey of all of the things DoD's got going on in the microgrid space, about 50 different plans or projects at the demo stage. They're classifying them and comparing the relative cost effectiveness. I would say if there is a single finding, it's that no one size fits all. The microgrid storage solution is going to vary from base to base, depending on the base's needs, their assets, and the local electricity market. ICF, the folks that did the terrific study of solar potential, are doing a case study of the financial benefits from electricity security technologies. such as on-site generation and V2G, load management. They'll be looking at 3 installations in 3 different electricity markets. And then finally, BENS, Business Executives for National Security, a very prestigious nonprofit, nonpartisan group, is just wrapping up a study on deployment of microgrids on military installations, looking at alternative business models, what the appropriate scale and scope should be. Should the microgrid end at the fence line or incorporate key things in the adjacent community? I think the answer to that is yes. What are the impediments to deployment? I have a draft of the BENS report, which I'm going to read on the plane on the way back, and I think we'll be putting that and they'll put that out within a couple of weeks, and the MIT study will be out. And so I think those will go a long way toward helping us understand this problem. And then finally, leveraging advanced technology. We are in the energy space. We have played a leading role as a R&D performer historically in a lot of areas. That will not be the case by and large in the energy space, and it will certainly not be the case when it comes to facility energy. That is DOD's role and the role of industry. But where we can play a major role is using our bases as a distributed testbed to demonstrate promising pre-commercial technologies. And our formal effort to do this is led by a group that I oversee, Environmental Security Technology Certification Program, ESTCP. It was created to do demonstrations of environmental technology, cleanup and other technology on our installations. They've had a terrific track record, and energy technology has a lot in common with environmental technology. So ESTP started up this energy testbed program with $20 million in ARRA stimulus funding. I have fought to keep it going and to grow it. And I think it has tremendous potential. It's a variation on the DARPA approach, where DOD pays a lot in the beginning to get performance, and then the cost comes down over time. Installations are commercial activities. We're looking for technology that is cost effective. We're not in a position to pay a lot extra for it initially. So we approach this in a different way. And the model, the notion is simple, that these emerging technologies hold tremendous promise for us with our 300,000 buildings, but they face a variety of barriers that lead to the valley of death that Secretary Chu talked about. The high cost to the first user that is not does not carry any additional benefit as first user often gets in the IT sector, in the pharma sector, for example. So we think we are uniquely positioned to help overcome these barriers to commercialization because, for a couple of reasons. With 300,000 buildings, it is in our direct self-interest to do this. We think about risk differently with 300,000 buildings. If we try 10 things and 7 of them work and 3 don't, that's great. We can deploy those 7 successful ones and come out way ahead. That's not true for many other building owners. Walmart is actually one of the other entities that has its own test bed, but they're focused on big box stores. We're focused on a much broader array of technologies. We have a long history of being a sophisticated first adopter and then being able to jumpstart the commercial market through our demand. And the culture of demonstration and validation, or test and evaluation, we call it DEMVAL. It's very deep. That is very, very much part of the DoD culture. People take that very seriously, and so that makes us an excellent test bed. Our test bed is focused in 3 broad areas: smart, secure installations, and that's primarily microgrids and storage; efficient integrated buildings; and on-site generation. Let me give you a couple of examples of each of these. We've got 10 demos going of microgrids and storage technologies at different installations. We're demonstrating multiple vendors technologies because we want to ensure that there's competition at the end of the day. So GE's at 29 Palms, a Marine Corps facility in the Mojave Desert. Lockheed Martin's at Fort Bliss. Eaton's at Fort Sill. United Technologies at Joint Base McGuire-Dix Lakehurst in New Jersey, and a number of storage technologies. These are the major players. The major microgrid players are the defense companies. It's an integrative function. It requires integrating a lot of other technologies, and that's what some of the big defense primes do. So it's a very nice space in which they are hoping to play a major role. In the building, efficient integrated buildings, in the area of components, and let me just mention a couple, I'll mention two that have a strong shared DNA with DOE. Electrochromic windows, these are self-tinting windows. They darken when the sun's rays are at the harshest, like glasses do. The big benefit of this technology is that you can reduce the size of the chiller in a new building or a renovated building. But no, and it's typically an A&E firm that decides how big the chiller needs to be in a building. They're not going to take a chance on putting in a chiller downsizing their chiller without really rigorous data on the performance of these windows and evidence on how people like to work in buildings that have these windows. So DOE has put money into electrochromic windows. Historically, there are two venture capital, or there are two firms with venture capital backing. Solidigm is the one that we're working with. They're still expensive and not in widespread use. We're going to demonstrate them at scale on three sides of a building at Miramar Marine Corps Air Station in San Diego. The lower left, nanotechnology HVAC, this is an ARPA-E-funded technology. This is a patented nanomembrane that dehumidifies air without having to cool it. Again, it's a way to substantially lower cooling costs and allow for a much smaller chiller ultimately. We're going to be testing this at Robins Air Force Base in Georgia in a humid climate. A lot of the technologies that we're working on will allow, a couple of these allow us to more cost effectively gauge where we should be investing our limited dollars in doing energy efficiency retrofits. First Fuel has a system that does it remotely based on metering data, satellite data, weather data. Drive-by thermal imaging is an MIT spinoff. So a couple different approaches. The lower right, continuous building commissioning. This is something Secretary Chu often talks about. This has tremendous potential. If we could operate our buildings more efficiently, that offers enormous gains. This is a system we're working with United Technologies on that uses automated sensors and advanced modeling to adjust building controls in real time to maintain the optimal performance. Now, there are systems like this in use in a couple of very high-end buildings. Our goal is to get the cost down so we can deploy this at scale. And then finally, and these are some of the players in the building efficiency area, and it's a mix of big firms and small firms. The next area, on-site generation, and this is dominated almost entirely by small firms. The lower right is, I think it's Solient. You all know more about some of these than I do. I added a couple that I'm not used to talking about. I believe it's Solient concentrating PV system. We're demonstrating that. We're just installing that. Two 25 kilowatt systems at China Lake Naval Air Force. It's a Navy base in the Mojave Desert. Grid parity solar power in the lower left. That's nanosolar. That's a technology that where using a nanoparticle ink that's printed directly onto an aluminum foil kind of material. Brings the cost of manufacturing down substantially. We think it has real promise for grid parity prices, and we're testing that at Camp Roberts in California. There was an earlier test of that technology at another military base that we didn't ever see that. It was the result of I think a congressional earmark at a facility in Ohio, and the results the results were not nearly as good as what's coming out in California. And I think it just goes to show that when you do one of these DEM valves, it's important to do it in the right place. And we work very closely we're very careful in figuring out the right working with the services and different installations to figure out the best place to demonstrate these. In the upper right, it's not solar, but I just want to give it a plug. Flex Energy, it's a microturbine that will allow us to generate electricity on really old landfills. We have several hundred landfills. We have a lot of very old landfills, and we can no longer generate electricity from them because the BTU content of the waste gas is so low. This microturbine technology will allow us to do that. We're testing that at Fort Benning in Georgia. We're nearing the end of the test. We've had issues with an armadillo, among other things, but we think it'll be successful, and there are any number of people who are watching this demonstration with their checkbooks in hand, ready to try it out if it works for us. And if it works here for us, there are scores of other places where we can deploy it. So you've heard of cool roofs in the upper left. This is hot roofs. This is a technology developed by John Archibald, who used to run DOE's FEMP, Federal Energy Management Program. Fans and ducts conduct the hot air from a traditional metal roof into the building, and we're testing this on a fitness center at Fort Meade, and we think it can generate enough energy to roughly a third or a half of the energy needs for the entire building. As I said, these are almost entirely small and startup companies. These awards come from a very, very rigorous competition that has been way oversubscribed. So we're talking about a $30 million a year program, and we've been getting 500 and 600 applications a year. So the acceptance rate is lower than the admittance rate to Harvard and Yale. It's very low. We don't like having it be that low. We want to expand the program. But another thing that we're doing is through our partnership with DOE is to take DOE technologies directly. DOE has selected them through a competitive process and take them directly. And the first example of that, since Secretary Chu didn't announce it, I won't say the company, but the company that will be named today as the winner of the SunPath competition, we will be demonstrating that very cutting-edge PV technology on 2 military installations at the 1 megawatt scale. Fort Irwin in California is one, and we haven't selected the second one. It will probably be somewhere in the California high desert. DOE will pay for the cost of the modules. We will pay for the balance of systems and the cost of installations. This is a huge win-win for us. We get cutting-edge technology. DOE gets our rigorous approach to demonstration and validation, and at the end of the day, we're a potentially very, very large customer. So we are very, very excited about this opportunity to partner with SunShot on this, and I think SunShot and DoD are eager to expand this, and we're looking to do something similar in the way of partnering with DOE's building R&D program. So there are countless ways in which we are partnering with DOE, but through our MOU, I could have given an entire talk just on that, but this is the most recent and the most exciting. So we're pursuing a multi-pronged strategy to reduce our costs and improve our energy security. Renewable and on-site energy is critical to that if it's connected to microgrids and storage. The services have very ambitious efforts underway. We have the land and the demand. We're not yet agile. This is our own vision of a flow chart, and this definitely would have crashed the computer if it had moving parts. This is the weapon system side of DoD. We do use a somewhat more streamlined procurement process for things like renewable energy, but it's still complex, and we're figuring it out. But we're committed, and I think we're ultimately a very good customer. And finally, with our 300,000 buildings and our thousands of acres of solar-compatible land, military installations can be a significant platform for innovation. And in this space, DoD and DOE are absolute natural partners. There's a very synergistic relationship, and we look forward to working ever more closely with you all. Thank you very much.